Hello everyone, today we'll be discussing how to create a speech dataset for ASR, TTS, and other speech tasks. Let's start with an introduction. A speech corpus is essentially a collection of audio recordings paired with specific labels tailored to the task at hand. For ASR, it's audio to text, for TTS, it's text to audio, and for speaker identification, it's audio to speaker label. Audio data can come from various sources like podcasts, YouTube, and talk shows, provided we have permission to use them. Continuing our introduction, there are several important factors to consider. Audio quality is crucial. Background noise or artifacts can hinder model training. The availability of transcriptions is also key, as many recordings may lack accurate text data. Speaker overlap can complicate labeling, and long-form content may need segmentation and alignment. Finally, ensure the audio is relevant to your specific speech-related task. Now, let's dive into some key considerations for building a speech corpus, starting with sampling frequency. For ASR, 16 kHz is the standard in research and production. Higher rates don't necessarily improve performance but do increase processing time, while 8 kHz might reduce accuracy. For TTS, higher quality is needed, so common rates are 22.05 kHz, 32 kHz, 44.1 kHz, and 48 kHz, as 16 kHz is often too low. Another key aspect is audio format and encoding. The most popular file format is .wav. The audio is often stored using linear PCM encoding. Some encodings are lossless, preserving all the original data, while others are lossy, sacrificing some data for smaller file sizes. Let's consider the length of recordings. For automatic speech recognition, keep audio samples shorter than 30 seconds, ideally 10 to 15 seconds. Shorter clips are better, especially for models using RNNs, to avoid long-term dependency issues. Also, try to maintain small duration variance across samples for better model performance. For text-to-speech, split recordings by sentence boundaries, not just silence. This helps the model learn sentence-level prosody and long-term speech patterns. For other speech classification tasks, like gender or speaker identification, only 2 to 4 seconds of audio may be sufficient to capture the unique characteristics of each class. Labels are also important. The specific label depends on the task. For automatic speech translation, the label is the text in the target language, which may differ from the audio's language. Maintain a balanced sample-to-label ratio. For example, in speaker identification, each speaker should have a similar number of samples. Imbalances can cause the model to learn irrelevant traits and ignore important signals, but techniques like sampling methods and specialized loss functions can help. Finally, let's look at speaker characteristics. More speakers lead to better generalization for acoustic models and ensure diverse validation and test samples. Aim for a balanced gender representation, approximately 50% male and 50% female, as male and female voices have different prosodic features. Ideally, include all age groups, with children,